Hello, everybody. We're going to talk about Chapter 5, Section 2 today. It's still polynomials. We're looking at linear factors and zeros. So really, most of the stuff we are doing today is going to be a refresher over some stuff that we did in Chapter 4, but we're applying it to higher degree polynomials. So Chapter 4 was all about quadratics, second degree. This example is a cubic, a third degree polynomial. But it's the same principle that we used in Chapter 4. So if I want to factor this polynomial, I would first look to see if there is a greatest common factor that I can pull out. So as I look, I have three coefficients here, -2, 4, and 30. Those are all even numbers, and I can factor a 2 out of all of them. So we know I can factor out a 2. Because the leading coefficient is negative, I'm going to factor out a -2. And finally, you also need to not forget to look at the variables. We have x cubed, x squared, and x, which means they all have an x factor that can factor out. So now if I factor out a -2x, we get -2x times the quantity x squared. When I divide that out of here, the -2 divides out x cubed, take one of the x's away, it's x squared. Then we take -2 out of 4 and we get -2. Take x out of x squared, we get x. And then take -2 out of 30, we get -15. Take x out of x, they divide out. So there's my first step. I've factored out the greatest common factor of -2x. Now we should be able to factor this quadratic, hopefully, too. If you remember how we do that, we're looking for two numbers that multiply together to get -15 and add together to get -2. So if you need, we can make this table here. We're looking for factors of -15. And we're going to see what their sum is over here. So we can always do 1 and 15. If I want them to multiply to be negative, I need one of these two numbers to be negative. And if I want them to add to be a -2, it should be the bigger number, the 15 that's negative. But these add together to get -14. So now we need to look for another pair of numbers that multiply together to get -15. So the other way to get 15 is 3 and 5. And we said we want to make the bigger number negative. This time we do have a sum of -2. So we need a 3 and a -5 in as our factors. And if I'm just factoring the polynomial, I can be done right there. Now we're going to talk a little bit about finding the zeros of a polynomial. So this one's already factored. If I want to find the zeros, this is x minus 1, that quantity multiplied by the quantity x plus 1, and that multiplied by the quantity x minus 2. And if it equals 0, then we've got three things multiplied together getting 0, meaning at least one of those things has to be 0. So we've got x minus 1 is one of them. We can say x minus 1 is 0. Or x plus 1 could be 0. Or x minus 2 could be 0. Now these are just three one-step equations for me to solve. That shouldn't take too long. Here I'll add 1 to both sides and get x equals 1 is one of my answers. Here I'll subtract 1 from both sides and get x equals -1 as an answer. And here I'll add 2 to both sides and get x equals 2 as an answer. So we've got three answers to this equation: x equals 1, x equals -1, and x equals 2. And then I've got one more example that we'll look at that's pretty similar to this one, and that will wrap us up for today. So we've got x times the quantity x plus 5 times the quantity x minus 5 equals 0. This is still three things multiplied together to get 0, so one of them has to be 0. We could say x plus 5 would make 0, or x minus 5 would make 0, but it also works if x is 0. So then this one's already solved for. X equals 0 is just an answer already. If I subtract 5 from both sides here, I get x equals -5. If I add 5 to both sides here, I get x equals +5. So we have three answers to this equation. X can be 0, -5, or +5.